Hello everyone. We are continuing with our public policy evaluation module. So, in this lecture, we will be discussing the broad aspects of experimental and non experimental methods. And coming to the experimental method, we will be discussing the randomized control trial, right? And we will be discussing some of the essentials regarding the randomized control trials with examples. Okay, so now we can discuss with the broad evaluation methods for policy appraisals or program appraisals. So basically, the evaluation methods can be divided into two broad parts. The first one is experimental evaluation, and the second one is the non-experimental evaluation. So under the experimental evaluations, we are taking the true experiments, that is randomized control trials, and under the non-experimental evaluation, we are taking into account the natural experiments, DID, regression discontinuity design, propensity score, and others. Okay, but today we'll be focusing on this aspect only, the first part of this. So let's discuss about randomized evaluation experimental design. What is that? So in literature, this randomized evaluation or experimental design is said to be the gold standard, right? Because these in a randomized control trials, so they are considered to be the best way to estimate the program's impact or policy's impact, because again through this randomization processes, they randomly assign the participants or members to a population, either to a treatment group, right? Treatment group means those who participate in the program, or the control group, that means those who do not participate in the program. Okay, so broadly we are saying that the members or participants are randomly assigned to broadly two groups. One is your control group, and the second one is your treatment group. Okay, so that is the reason it is known as the gold standard, because it randomly assigns the participants in two different groups. Okay, and because of some other features also associated with this randomization processes. Okay, so we can say that this is a gold standard in experimental design. Okay, so the first thing is that while distributing the groups, that is between the treatment group and control group, we need to ensure that both the groups should be of uniform characteristics. Okay, so that means in both the groups we should find similar observed characteristics as well as unobserved characteristics. So the process of randomization ensures this similarity across the groups. Okay, be it control group or the experimental group, for certain characteristics, like the characteristics which can be observed. Okay, so for example, we can say variables like age or sex, right? So they are observed characteristics across the groups. Okay, likewise, through this randomization processes, it also ensures that how the unobserved characteristics can also be similar across the groups. So what are those unobserved characteristics that are also to be similar across the groups? So these characteristics could be the personal preferences or motivations, okay, or confidence level, you can say the interest to learn something or the interest to participate. Okay, so or the courage. So all these are the personal preferences. Okay, so they are largely unobserved characteristics. Okay, but when we are dividing the group into the treatment group and the control group, so this randomization process ensures that the characteristics across the groups, okay, should be similar. So maybe it is the characteristics are the observed characteristics or the unobserved characteristics. Okay, so since again we can say that since we ensured that both the groups are of similar nature, then we can say that they are identical. That means both the groups are identical except for the intervention, right, or except the program or policy that is considered. So that may make a difference in outcomes between these two groups. Okay, and the difference in outcomes can directly be attributed to the intervention. Okay, so that is what is known as the causal attribution. So what is causal attribution? Causal attribution is the outcomes that can be directly attributed to the program or intervention itself. Okay, so again we are saying that while doing this randomizations and the and designing the experimental processes, we can find a causal inference. So what is this causal inference, or how can we ensure that causal inference is being observed here? Because again, randomization ensures that the groups are similar, right, in both the characteristics observed and unobserved, right, and any differences in outcomes, if at all, that can be attributed to the intervention or program itself. Okay, so that is the reason we can find a causal inference or cause and effect relationship, that it is because of the program or intervention itself the differences in outcomes are being observed. Okay, so here we can find the how to set up a randomized evaluation. Okay, so we can find that the target population. Okay, we can also from this target population we can find the potential participants and also the evaluation sample. Okay, and from this evaluation sample we have to randomly assign these participants or members into two broad groups, as I told you, that one is your treatment group and second one is the control group. So treatment group is the group that where the program is intervened, right, and control group there is no such mechanisms. Okay, so again in treatment group where the intervention is made, right, we can find some of the members who are offered the intervention can actually participate and some of them may not participate, so they are known as no shows. Okay, so given this sketch of how to set up a randomized evaluation, we can also discuss that what exactly are those, how to define these groups, and accordingly you can subcategorize and finally do control groups and the treatment group. Okay, so first of all we discussed what is known as the target population. What is this target population? So of course this is a broad group of the program, right, or you can say the broad group that the program is intended to target or intended to benefit. Okay, so this is a broad population. Okay, and coming to the next one after target population, so we have to identify which are the potential participants. That means within this target population, okay, some may not be able or may not be willing to participate. Okay, so that means the study focuses on those who are both eligible and willing, right, and this group is known as the potential participant, which is a subset of your target population. Okay, then coming to the third tier would be the evaluation sample. Okay, so what is this evaluation sample, or who are consisting of this evaluation sample? Again, it is a part of your potential sample. From this potential sample we are drawing this evaluation sample. So here a random sample is drawn, right, from these potential participants, right, to constitute our study group. Okay, so once we find this study group, then we can go for randomization, assigning the members randomly. Okay, so that is your random assignment. So here basically the members of the evaluation sample are randomly grouped into two parts. One is your intervention group, second one is your control group. So what is your intervention group or treatment group? So this group participates in the intervention or the program where program is being implemented. So that group is known as the treatment group, and where the members do not participate in the program, so that group is known as the control group, or symbolically we can say here p equal to 0, that means there is no intervention. Okay, or the participants do not participate in the program. Okay, so and the purpose of this control group is just for a comparison, right, since in the treatment group the program is intervened. Okay, or participants in this treatment group they observe the program, right, and given this understanding, now we can check with that what is the power of RCT. So actually the importance of RCT lies in that how effectively it handles both the observed characteristics and unobserved characteristics. Okay, and making both the groups similar. Okay, so that we have already discussed. So again we discussed that how to, since we have to again reflect these characteristics in our sample, right, while preparing this control group and your treatment group. So, these are some of the essential things that we need to take into account while doing this this experiment. Okay. So, the first is your object characteristics. Okay. So, that needs to be similar, okay, across the groups, and on object characteristics also need to be similar across groups. So, I am just taking an example. Let us say that if the evaluation sample consists of 40% female both, then we need to ensure that both the treatment group and control group should have approximately 40% female. Okay. So, this is one of the object characteristics, that how the evaluation sample, right, evaluation sample, the components of the evaluation sample should be reflecting the treatment sample and the control group sample. Okay. So, the other characteristics like your education level, so it is again observable. So, if the evaluation sample is having, let us say, 30% of education level in higher secondary education, so the treatment group and control group must also have approximately this percentage. Okay. So, likewise in the unobserved characteristics also, so the similar characteristics should be observed across the groups, right. So, what is this unobserved characteristics? As I told you that these are basically the traits, and unlike this observed characteristics, okay, which is a bit easy to identify, okay, and observe, these unobserved characteristics are really difficult to measure. Okay. So, for example, it is difficult to measure the participants motivation, preferences, and even the personal grit. Okay. So, that is the reason randomization ensures that these unobserved factors are also similar across the control group and the treatment group. Okay. So, here is a sketch that how the randomization process should be undertaken. So, this basically reflects the characteristics of groups under randomized assignment. So, this is our evaluation sample, right. So, if evaluation sample is consisting of 40% female, 20% college degree, 20% extrovert, right, or 30% participants who like pizza, then in the treatment group and control group also the similar characteristics must, approximately similar characteristics must reflect. Okay. So, 40% female participate, this is 20%, this is also 20%, this is also 20%, and likewise. So, you can check that how similarity is being ensured. So, again here while doing these experiments, because we followed randomizations, and randomizations ensure that the groups are identical except the intervention of the program, then the average impact of the program, which is also known as the average treatment effect. Okay. Average impact of the program is known as the average treatment effect. So, this average treatment effect can be recovered simply by comparing the mean outcomes of the treatment group and those of the control group. So, mean outcomes of the treatment group and mean outcomes of the control groups are compared here, and we found what is known as the average treatment effect. So, this average treatment effect is nothing but it shows the average program impact or average policy impact. Okay. And if you are considering an ideal case, so in an ideal case what happens that everyone follows their random assignments. So, suppose say that we have divided the groups, right, into control and intervention or treatment groups, right, and here let us say that A, B, C, D members are assigned to the treatment, okay, randomly, and X, Y, Z participants are randomly assigned to the control group. Okay. So, in an ideal situation actually what happens, everyone follows their random assignment. So, there is no way that C will be saying that I will not be here in treatment group, rather I will be mixing to the control group, or X cannot say that I cannot be under control group, I will be under this treatment group. Okay. So, that means everyone follows their random assignment, and any difference if at all is found, that is because of the causal impact of the intervention or causal impact of our program. Okay. So, given this background information, now let us understand that how does randomization solve the program evaluation problem. Okay. So, perhaps you remember that what is the evaluation problem that we discussed. The main evaluation problem is of creating or finding the data of our counterfactual, Okay, so just to refresh your memory, that what we have already discussed in our previous classes. So, and we need to understand that how randomization solves this program evaluation problem. Okay, so we can say that this randomization can solve this evaluation problem, basically counterfactuals, by using what is known as the random assignment to create two groups. One is treatment group and the other one is control group, and these are statistically identical, right, as I just discussed, in every respect except what, except their participation in this program, which is acting as an intervention. Okay, so this process of randomization then allows the policy analyst to overcome what is the fundamental problem, and the fundamental problem that I just highlighted is the problem of counterfactual. That means, what is this counterfactual? That means we need to know the researchers can overcome this particular counterfactual problems of the impact evaluation, that is the inability to observe both the treated and untreated status for the same individual at the same time. Okay, so this particular data, which is quite not possible, okay, can be made possible through this randomization process or random assignments. Okay, so now the evaluation problem is essentially that we are highlighting its counterfactual problem. So that is what the missing data problem, because if we are finding that what is exactly the status of a particular program right now, if participants are participating, okay, the counterfactual is not available to us. That means we cannot compare because there is a missing data problem, and this missing data problem can be corrected if we can develop this random assignment processes. Okay, so for any participant we can observe their outcome, right, with the program, but we cannot actually observe what would have happened to them without it. That is your counterfactual. So if the outcome with the program is y1, then the outcome without the program is y0, which is largely missing, or we are not able to get the data which through this particular problem can be corrected through this randomization. So randomization solves this by at least two broad ways. The first one is that randomization ensures group similarity, that means across our control group and across our treatment group, so we have similarity. And the second is that through this randomization process we create a valid counterfactual. Okay, through these two processes we find we solve this missing data problem, or we counter and fix the counterfactual problem of our experiment. Okay, so let's consider we are taking a case of ideal situation. In an ideal situation, whatever the random assignments are taken into account, so that would be 100 the members would be following it completely. That means in an ideal case there would be 100% compliance where everyone follows their random assignment. Okay, as I told you that if there are three participants in our treatment group and 3 in the control group, so they would be sticking to their groups, so they are not going to change their groups. Okay, so everyone follows their random assignments. Okay, so that means if these 3 are assigned to this particular group, then since they follow it, right, so that is the reason we can say that 100% compliance is being observed by this participant in sticking to their groups. Okay, so they followed this random assignment. Okay, in this case, when 100% compliance is found, then we can find the effect of the intervention of a policy or program through what is known as the average treatment effect. So what is this average treatment effect? So this is recovered through the difference between the two groups, that is your control group and your treatment group. So this average treatment effect, which captures the impact of the intervention, right, is found by identifying the difference between the two groups. So this is your treatment group and this is your control group. Okay, so what is this? So we are trying to find out what is the expected outcomes where individual randomly participates. Okay, or where individuals was randomly assigned to the treatment group. Okay. So, R equal to 1 means the individuals randomly assigned to the treatment group, and here expected outcomes where individual was randomly assigned to which group? The second group, that is a comparison group or a control group. Okay. So, R equal to 1 means your individual was randomly assigned to the treatment group, and R equal to 0 means the individual was randomly assigned to the control group. Okay. But many times what happens, this compliance is not 100%. So, that means even though out of these three, right, three persons who are assigned to the group, treatment group, okay. So, out of these three, one may be able to participate in this treatment group. Okay. So, that means it is a case of non-compliance. Okay. So, in case of non-compliance, still randomization can also work. That means randomization can provide a particular framework for solving the evaluation problem even when the individuals do not follow their assignments. Okay. So, earlier in our graphical framework we have just discussed this particular group as no shows, right, in the treatment group, because although they are assigned but they are not participating in the treatment group. Okay. So, when individuals assigned to the treatment group and they choose not to participate, so that means it is the participation is not voluntary, it's not compulsory, rather voluntary. So, that is the reason this particular group is there, which is known as the no show group. Okay. And here basically it complicates the evaluation altogether, because we can no longer directly observe what is known as the impact of the program or impact of the policy in terms of average treatment effect for the entire population. Okay. So, what happens here? Here we are trying to see that random assignment is there, but some individuals chose not to participate. Then what happens? So, again random assignment is decided. Okay. Treatment group and control group, but in the treatment group itself, some are participating and some are not participating, although they are grouped under this, they are assigned under this group, that is treatment group. Okay. So, in this case, how to evaluate or how randomization process can help us in finding the evaluation, policy evaluation. So, in this case also, even we are finding that there are non-participation. Okay. So, the policy analyst can still recover very meaningful estimates of the program impact using some approaches. So, what are the approaches? Two broad approaches at least can be followed by the policy analyst. The first one is known as estimating average treatment effect on treated. So, it is not, we are not, in this case we are not going to find out what is average treatment effect. Okay. So, average treatment effect is meaningful to capture the impact of the policy or program when 100% participation or 100% compliance is followed. Okay. But in case of the evaluation where 100% compliance is not followed, then the average treatment effect is not going to be helpful, or average treatment effect is not going to capture the impact of the policy or intervention. Okay. So, that is the reason we are using two other approaches, right, to find out what is the impact of the policy or program. So, the first one is estimating the average treatment effect on the treated, that is your ATT. Okay. Average treatment effect on treated. So, what is this average treatment effect on treated? So, this particular estimate or estimate you can find when there will be no participation. Okay. When there will be no participation, and this average treatment effect cannot be estimated. Okay. When there will be no participation, then of course, as I told you, the average treatment effect cannot be estimated, because outcome with the program, that is that we are reflecting as y1, is never observed for those who do not participate or who refuse to participate. Okay. So, that is the reason our AT is not going to be estimated, or it is not sufficient to capture the impact. But the impact of those who actually participated can be captured through what is known as the average treatment effect on the treated who actually participated, right. So, who actually participated, they are assigned in the treatment group and they actually participated, right. So, this group is not taken So that means no show group is not here. So the impact of those who actually participated can be captured through this ATT. Okay, and again, so this ATT can be captured through a method that is known as the inflation method. So for estimating our ATT, average treatment effect on treated, the policy analyst can take into account the difference between the mean outcomes of what? Mean outcomes of those assigned to the treatment group and those assigned to the control group. Okay, mean outcomes of those members who are assigned to the treatment group and mean outcomes of those participants who are assigned to the control group. Okay, once we are finding this difference, then we have to inflate it. Okay, so how to inflate it? So that means we need to divide these differences by the fraction of the treatment group that actually participated. So that means out of, let's say in our example, that out of three participants, those who are assigned under this treatment group, one did not participate. So that means two participated. So that means this is the actual participation by only two participants, not three. Okay, so here we are going to divide this difference by the fraction of the treatment group that actually participated. Okay, so we can use this formula. So in order to estimate this average treatment effect, what is this average treatment effect? Is the difference between these two, the expectations or the mean outcomes of these two groups divided by the fraction of the treatment group that actually participated. Okay, so here we can find this R means random assignment. Okay, R1 means they have participated and the random assignment is done, and here R0 means it is the case of your control group. That means no program is there, they are considered under the control group. And here P means participation. P is the actual participation in what? In the treatment group. That means R equal to 1. So in this group, what is the actual participation? Okay, so if we take a simple difference, that if you are doing this only, right, then it means between the two assigned groups, right, between the two assigned groups we are going to draw a difference. So this simple difference in means between these two groups, it can underestimate the impact of the policy. So why? Because it includes people for whom the program had no effect. So in this group also we are including the no show off. Okay, so in order to also separate them and in order to find a robust calculation, what we are doing, we are dividing the participation rate. Okay, and by dividing the participation rate here, it can correct this underestimation. Okay, and the second method that we can also find is using the intention to treat, ITT effect, intention to treat effect. So because since we are finding that in case of this intervention group, okay, our treatment group, there could be non-participation, and because of this non-participation we can estimate what is known as the intention to treat. So what is this intention to treat? That means the average impact of the program or policy among everyone offered the treatment, regardless whether they have accepted it or not. Okay, so that means we can say ITT, this intention to treat, can be calculated as the difference between the mean outcomes between the group randomly offered the program and the groups randomly not offered the program. Okay, so now we can find it. So ITT equal to what? ITT equal to what? The expectation of the outcomes where the program is randomly launched, right, and expectation of the outcomes of that group where the program is not offered. Okay, so and if you find this one, if there is full participation or 100% participation, so that is termed as your average treatment effect. But since there is not 100% participation, that means non-participation case is there, so this difference is known as the intention to treat. Okay, so what is the relevance of this intention to treat? So this intention to treat is really very important because it provides the policymaker some useful information. Why? Because this ITT can reflect the real world impact of making a program available to a particular targeted population and accounting for the fact that some will deliberately or inevitably choose not to take the intervention. Okay, so that is the reason it has the policy relevance as well. And when everyone complies, okay, as I just discussing, when everyone complies fully with their group assignment, that means 100% participation in the treatment group or 0% crossover in the control, then this ITT becomes your ATE. That means your intention to treat effect would be your average treatment effect that captures the impact of the policy or program. So for that reason we have to take some obey some assumptions as well. So here we have to take that there is no contamination of the control group. That means whatever the assignment was there, right, the members should not have any freedom to mix with each other. So no contamination of the control group. It is assumed that no one in the control group was able to participate in the program. So from the control group, right, no members can come here. Okay, so that is the first assumptions while designing this experiment. And the second one is there is no spillover effects. That means it is initially assumed that those in the treatment group who chose not to participate were not indirectly affected by those who did participate. Okay, so but in case of some example, like let's say there are some infectious disease, okay, spread of infectious disease, so as a result vaccination programs were intervened, some participated and some did not want to participate, okay, or the others do not even participate. So in this case what happened, that those who have participated, right, since it is contagious, so their act can impact those who are not participate, those who have not participated. Okay, so but here we are saying that there is no spillover effect, that we need to design our groups in such a way that the treatment group who chose not to participate, we are not indirectly affected by those who participate. But here in this example we are not finding so. Okay, and if at all, let's say in the example like this, that spillovers are existing, then this ITT, that is your intention to treat, okay, this estimate remains a valid measure of the total impact of the offer, but your average treatment of the treated can no longer be estimated using the method that we discussed, that is your inflation method. Okay, and again because we are trying to estimate the overall average treatment effect across the entire population, which are really becoming difficult under non-compliance. Okay, so the policy analyst use some other methods like instrumental variables, okay, such as you can say the initial randomization or initial randomized assignment to recover the local average treatment effect, and this is also known as the complier average treatment effect. Okay, so given this understanding, now we can discuss about the takeaways, that through this randomization process, how can we solve the fundamental problems of our evaluation. Okay, so randomization since converts the impossible task of observing two states, right, for one person's during a same time into a straightforward comparison of two identical groups, right, that is treatment group and your control group. So thereby it allows for causal attribution of the program's impact. Okay, so here basically we discussed about some estimates, like the several type of treatment effects that can be estimated depending upon the behavior, participants behavior. We discuss average treatment effect, we discuss average treatment effect on the treated, we discuss intention to treat, and also discuss the local average treatment effect. Okay, so but what we are finding is that there are challenges, lots of challenges in implementing this particular design, randomization design, randomized control trial design, because practical issues can also arise where we can find non-compliance with the random assignments, or we can say that sample attrition or participants may leave in the ongoing study, or contamination bias or randomization bias, or even due to some ethical reasons. Okay, so So these practical complications can be in form of no participation or no show, that we have already discussed, right? Although they are in the group, but they preferred not to participate in that particular program. So when some people assigned to the treatment group, but they deliberately chose not to participate, then this average treatment effect can no longer be estimated directly. Instead of it, we can calculate ITT or our ATT depending upon assumptions. Okay. So the other practical complications that we are finding is spillover effects that we have already discussed, encouragement of designs. Okay. So that means if you can say that in the treatment group some are not interested to participate, we can go for encouragement, like giving a kind of incentive or voucher or extra information, right? So thereby we are designing or including encouragement designs, right? So the evaluators cannot directly control the participation, they can randomly assign this encouragement, like extra information or vouchers. Okay. And when we are including this encouragement designs, right, so this particular process assigns the policy analyst to estimate the local average treatment. Okay. And that is what, or this local average treatment is the impact on the compliers. Who are the compliers? Those who only participated because of there was some kind of encouragement to do so. Okay. So given this understanding, now in the next class we'll be discussing some of the examples, right, and examples of our average treatment effect, right, and ATT and ITT, that how this can be calculated. Okay. Thank you.